Hi, good morning, good afternoon, good evening. My name is Amit Bahree. I'm a principal PM on the AI platform team at Microsoft. Thank you for spending the time with me and welcome to Data Platform Summit 2020 from my house to yours. Hope you're safe. I don't know anyone who's not been impacted by the pandemic. I feel lucky. The only thing I really have to worry about is this sort of mop on my head. It's probably a chicken head. But I wanted to take a few minutes today and talk to you about reinforcement learning and how that is powering this next set of AI, we're calling decision AI in cognitive services. So, few areas that we would cover today. Briefly touch on what's cognitive services. For some of you don't know, what is decision AI and how it enables us to build apps that change for the changing world. A brief introduction into reinforcement learning and sort of key aspects of what RL means. How are we using RL? We'll especially bring it to life with the personalizer and anomaly detector, two services uh, in the context of decision AI, and then give you a flavor of some of the stuff that's coming down the pipe, from sort of what we call research to production with MSR. Some Microsoft examples, and then open to questions as we go through this. So briefly, for those who don't know, cognitive services, we have these 5 categories of services. There's perception-based services that understand the world, speech, language, and vision. We have these new decision-based services that help you make an informed and efficient decision. And then finally, your search services that surface information from different and wide variety of sources that you sort of bring together. And then, of course, the real benefit of cognitive services is, you build your solutions, your use case with these proven AI services that you can deploy anywhere, whether it's on the cloud or edge, containers, and they're proven from an AI, RL, ML perspective. So you don't really need to have an AI expertise. Any developer can effectively pick them up and use them. They're exposed generally as a bunch of APIs. And then finally, they're responsibly built and trustworthy. So this notion of ethics and bias and understanding thereof is quite built in. And we'll touch on elements of these as we get into. But just on decision AI, it's sort of this newer category that we are building. And fundamentally, it's this which is allowing us to build apps that adapt to the changing world. Look, our behavior during the pandemic is messing up with the AI models that are in production today. What to those AI models, what's normal behavior doesn't seem normal now. What is our day-to-day behavior now seems sort of weird and different. And then sort of those models are showing cracks, and it's forcing behind the scenes. What most people don't realize is behind the scenes, it's forcing humans to interject and sort of fix them, if you will, right? So what does it really mean? So just real briefly, we have RL as a science of AI that makes decisions in the world, that learns, it acts on the world, it learns from that and sort of from the outcome and then acts differently as it's learning from that. And then as we talk to customers, we realized that we were all having this broader conversation that even in a perfect world with perfect knowledge and instant action, the differentiation for those customers was coming from this notion of adaptiveness, allowing them to differentiate these decisions in their world, right? And then also learn, right? The way you can only differentiate it is as this complex world around us is changing, those outcomes will need to be changed, right? So how do we they sort of rinse and repeat through that, right? And this was true across business decision makers, developers, data scientists, industry engineers. So even though we have this rich perception and interaction and knowledge and prediction, there's still a gap, or the way we see this sort of this huge opportunity on reasoning and planning, which is building on these, right? It's building on the knowledge and prediction that you have through knowledge graphs and other complex systems. It's using the perception and interaction. And this focus, at least most enterprises are on, is this notion of reasoning to, and planning, and it helps them automate things which may be monotonous. It helps them dynamically adapt to this changing world and from a decision perspective. And fundamentally, we believe it opens up bandwidth for employees to concentrate on matter and what's more important than sort of just, feeding an algorithm, if you will. It's what matters most to an outcome to your business. And then this just becomes one of the sort of cogs, if you will, to get to that. And then, of course, as we are seeing all around us, quite unfortunate, but COVID is a great example. Living and breathing is like this whole notion of dynamic learning is important. Changes to behaviors and habits can and do happen overnight. What was normal today or a week from today is very different from a month to 3 months to 6 months, right? And Darwin was the one who, quite eloquently put this together, right? So companies and enterprises that are creative in their responses and sort of constant innovation will be the ones who survive, whether it's fine-tuning something as an outcome, learning faster and the ability and the capacity to learn faster, or reform themselves as the world's shifting. However you want to think of through that, right? The ones who change to behaviors and habits fastest are the ones who will come out sort of the fittest. And when we say what this change of behavior is and how do they adapt, like what is that? What are the possibilities? So it can be quite smattering in a way, right? In one hand, we could talk about adapting to current context and situation, right? Every decision you're taking, how I'm changing every decision I'm taking. Sometimes that may be too granular. It's also thinking about like a rules engine. Most rule engines at the end of the day are still sort of, excuse me, hard-coded switch statements, fancy switch statements. And the idea is how can I sort of replace that with something that is continuously learning, and then in different environments, right? How do I adapt to different styles and environments? So there's various notions of how these you can think through. And that's something that decision allows you to do, right? It allows every customer to basically improve their business result. And the way they do that is AI that sort of falls into these three buckets. If you think about it as a mental model, there's AI that trigger decisions, which can allow me to make a better result. And the trigger point could be for various things. I'm getting an anomaly in a factory or a forecast or something. It allows me to make fundamentally step-by-step decisions, right? How can I choose a better action or conform and fit into a solution? Or I can improve. I've already decided something, but how can I make that decision better? How can I evaluate? And then also explain why am I taking that, for example, right? And I can learn from different environments and worlds. So in the end, what we're seeing and getting to is decision AI. This notion of decision AI will help enterprises make those basically timely decisions. And then examples of where we're seeing like enterprise scenarios. You sort of see three categories here. It's not just these three. These are just the ones more prevalent as we're seeing it now. So there's notion of system optimization and controls. So things like energy, grid optimization, industrial controls. I mean, telco and network is very, very hot right now that we're seeing, especially with many folks working remotely because of COVID. It was always important, and it's yet more. But one example, if you think about system optimization, is like again how we use it is I know an underlying VM may be about to crash, and I need to reboot it. So how can I reboot it and allocate networks accordingly, knowing I can plan for that? Another kind of optimization is on resource optimization and operations. So things like logistics, risk management, and so on. And then finally on adaptive experiences, how can I make the experiences better and adapted to my situation? A key area we're seeing people experiment right now is with remote learning or adaptive learning in remote learning because of school. In many parts of the world, schools have gone online and remote. And then how can you think through elements of that in the sense of learning? But the same notion goes back to even things like employee training and customer self-help. And we'll show you an example of that towards the end as we get into that as well. But then how can apps, when most apps you're building today, what is different that allows them to change, right? So today, again, we go back to a lot of AI in these apps is using perception and prediction. And as we expand onto that and start thinking about decisions and choosing the right action, the traditional way, the traditional three-tier architecture, if you will, is at a high level. If I abstract it, there's a UI, some sort of an interaction, This could be on a desktop, could be on a phone, could be a web app, could be voice. If you're talking to, let's say, a smart speaker, that is a UX of some sort. You have some middle tier, some business logic, and there's some backend of some sorts, right? It doesn't necessarily mean a database, could be a SaaS layer or a PaaS layer or what have you, right? But at a high level, sort of these are. And if you think about as you in this world, as you're wanting to or are transitioning from perception and prediction to reasoning and planning, sort of that those middle tiers and this decision AI sort of are your acting agents. They are sort of AI learning and AI acting agents that use a combination of supervised learning and reinforcement learning and other techniques. It's not just one thing, but it should be a multi-steps, multi-things that can combine and think through that, right? And almost because it's like an living, breathing sort of engine, if you will, in the middle. It's not hard coded or in one way, right? And these living, breathing things is the one that adapts as the world is changing. So, again, our normal behavior, what we see today, wasn't that normal 3 months ago, but these can adapt to that, right? That new normal, and they continue working. Another example is, like insurance claims. If you have to extract sentiment analysis or text and understand literally the word COVID, until now, if you're sort of in a traditional AI-powered app or a solution, it may or may not understand that, right? It sort of won't understand that. But in an adaptive world, your use cases, your business rules, your timelines, let's say in an insurance, like I said, to close an insurance claim or whatever, it understands COVID and things will be very, very different. So it can adapt and change your outcome to that. And then powering a bunch of this stuff is reinforcement learning. So I want to just quickly touch on that. Is if you think about most ML today, sort of this loop, right? I see stuff, things I may know about, I label them, I get all the data, I clean it up, I label it. Using that cleaned up data, I train it. I have a model which sees more things and sort of rinse and repeat. Now, to make that model better, we need to get more data and so on. At a high level, this is called teaching by example, right? I think most of you understand that today. But the real world is complex. It's messy. We don't understand the rules, the quality of the data, the speed of the data. What we want to do is all different. And guess what? Like in most ML, is if you think about if you've gone to a financial planner, the first thing you learn is past performance or past indicating performance indication is no guarantee of future results, right? So sometimes the past is not the best predictor of the future. The world is really, really unstable, right? And this notion of having a predictable baseline is quite obsolete in some ways. So reinforcement learning is the technique that allows us to experiment and learn from these, right? So this whole cycle, it's things I try in the world and I learn from that and update a model and sort of repeat. This whole thing happens in sort of digital speed, if you will, right? I can experiment with new patterns. This inherent in these two last points you see on there, this notion of creativity, curiosity, by exploring, we'll touch on that, and then ability to achieve a goal even when I don't understand my environment. It really thrives in that, right? Despite uncertainty. Whereas more ML traditional sort of models need the certainty. Their worldview or their environment is finite. They understand that. And if it deviates from that, then we have to sort of go train and label and so on and so forth. But here I can continue to augment it and actually deal with the uncertainty. I can still achieve that goal. So formally, what is reinforcement learning? So it's the study and the science and the problem of intelligence, and specifically in the form of an agent that interacts in an environment. You've heard me talk about environment a little bit, but the agent it can be anything. It's our code that's running in an app. It could be the codes that controlling. It could be the self-driving car, let's say, driving on a street, whereas the street is the environment. It could be a robotic arm on a factory floor. Could be any of these, right? So it's a loose term in that. And then the problem is given by the environment, i.e. the world where the agent is living in. So if you stick to the car analogy, just because mentally most people sort of get it quicker and can appreciate it quicker, right? So my environments, my roads and my streets, or the city I'm in, or the world, and the agent's the car, right? So and then the agent can take actions that have some impact on the environment. It's not completely disconnected, right? And then those actions have changes of things in the environment, right? That the effect is fed back as observations, right? What it sees and senses, how the environment is changing or adapting to those actions. So if you get to a traffic light, the car is stopping, and the notion of stopping is having an impact, for example, right? Or it changes, the light changes green, or the road is curving, or whatever, or there's traffic or pedestrians. And then one of these observations back is a special signal, which we call the reward signal. You'll hear a lot me talking about reward in the next few slides as we go through this. And the reward really signal tells us how good or bad something, an action was. Good or bad in the context of a goal that I'm trying to achieve. And at the end of the day, what RL, the problem it is trying to solve is, how can I take a series of these actions that interact with the environment over time is important, to maximize the special signal called a reward. So that is really what I want to do, is maximize those reward signals over time. And the reward signal equates to what my business outcome would need to be, right? So as we touched on, this maximization is without explicit supervision. So you're not training it or labeling it or teaching it, it's learning on its own. And then the real power of it comes is in the uncertain environment, when I could have a delayed or an indirect consequence to a reward of my action, it is baked into the system. So remember, just as in real life, sometimes I may be looking at a reward right up front, but sometimes we know not to go for something that looks really good, knowing that something will be much better down the road, right? We can sort of see it or foresee it or think through. And it's that same notion of a delayed reward or delayed consequences. And this reward signal sort of determines the good or bad, but it's not a binary. It's not on or off. It's a dial. It's a scalar between 0 and 1. And then we could understand from a business logic perspective, what does that mean? I touched on how time is a key component, and this notion of a delayed feedback is there, which is not there with the backprop, which is what you get in ML. And then sort of your current step affects the next step, the next data it receives, the next action, because the environment has changed. It has interacted with that environment. We're still keeping this high level. So types of RL, I mean, fundamentally there are two types: real world, which is what we will live in and what we will talk about, and there's a simulated world. Simulated world, in some ways, even though very complex, can be very complex, is learning from simulation. So I'm running something in a simulation, and that's my notion of the world. And then based on the outcome of that, I can sort of do something or not, right? Now, real world is more complex because just literally our real world is too complex to boil down to algorithms and steps and so on to be able to put it in a simulation. But then some things are much better off in the simulation. So if I have to simulate a robotic something, let's say on a factory floor, elements of that would be better off in a simulation because my known universe is quite, relatively speaking, small in that case, right? So it's not that real world is better than simulated world or vice versa. It just goes back to the problem statement that you are. But just at a high level, just understand, I guess, appreciate that the real world is much more complex because I cannot simulate it. That doesn't mean the simulated world is easy, but just too many dynamics in the real world. And then in RL itself, irrespective of those two, you can have this notion of a single step, that how do I take a single decision that allows me to get to a reward. There's something called contextual mandates or CBs. That's an example of that. Or I have this notion of multiple steps, right? Multiple decisions I want to take. Actually, not multiple steps that collectively improve overall outcomes. So like balancing an energy grid or a building temperature is not one. It's like each room could be different. Each section of a floor could be different. And I can have multiple tweaks and knobs to turn collectively or sequentially in some manner to be able to get it. So that's multi-steps. And then I could have multiple agents, which I don't think we'll cover today, which could be a local and a global and a combination thereof for sort of the greater good in the context of a goal, if you will. But it's also important to step back and mentally put this, right? I remember as I was getting more into RL, this is one of the things I struggled with. And many others I talk to also, have that. But RL is not better or the other is not better. It's another class of ML, right? So if you think about supervised, unsupervised, you need to think about RL in that same vein. They are complementary in many ways, and you should absolutely think about using more than one where you can and how you can. For a certain thing in a certain time, one technique would be better at that, and that's what is something you should do. And then in RL, as you're thinking those multi-steps or those sequence of actions, some of those actions could be calling on to these other ML techniques, so they're complementing each other. And then um, in RL, we'll talk about, I think, this notion of, there's two types of algorithms and methods in RL on. There's model-based and model-free, right? So model-based, either I learn a model and I understand sort of a better notion of my world, so I'm modeling what that world would look like, or I'm given a model, like with a lot of AlphaGo and AlphaZero in some cases, or it's model-free, right, where I have a policy that I'm trying to uh, uh, optimize, if you will, right? So in that, there's sort of two categories and then a combination of three called hybrids. This is really where a lot of what we operate in right now, just to give you a sense of things. And then with that, in the interest of time, just going to switch, to these first set of services that allow you to make decisions. And Personalize is the world's first RL-based enterprise services. We got a few awards around it, and basically it allows you to, uh, adapt and change as the world and the environment is changing, including unseen things in the future, things that are never seen. How can it adapt to that? That's really, and explore. That's really where the beauty of Personalizer comes in. But what is Personalizer? It's, at a very simple level, it's an AI service that helps let's say in your app or a solution to choose the best action. I have a list of options. What's the best option I want to do in the context of let's say a user? And then as a result, what's the relevant experience? And then over time, given relevant, those experiences improve over time based on the behavior, as the behavior is changing and it's adapting and so on. Key point here is it's not personalizing to an individual user, but it is about content and context across a class of individuals or a class of users or a class of things, and then best content or best thing, best option in that context. And those could be anything basically right now. You'll see a little later, but we use it internally in the guts of Azure, for example, to figure out which VM and which resource is going to die, so I can move a whole bunch of stuff. So to you as a user, you don't see anything. There's no interrupts. Everything just keeps working, right? So I have a menu of options. How do I know it's this thing versus, let's say, something else? And here's a few other examples you can think about: playlists and alerts and collections and contents or items, layouts, things to suggest from a menu which one should have show or not. And at a high level, how does it work, right? So we wanted to make it as simple as possible, so you don't get into any of the RL-based sort of gobbledygook. You can if you prefer to and want to, but the idea was to keep it simple, which is where most of our customers are, right? And then there's two simple APIs. One's called rank, one's called reward. And the whole idea is a user interacts with the site. There's some context and information about the user. There's a list of actions uh, to choose from. This is a news site, and the next one we'll sort of double click into a little more. I'm going to keep it a little high level in this one. So I have a list of articles on news site to, my actions to choose from. And then I call Personalizer to the rank API saying, hey, for this user in this context, here's those actions. Which actions can you rank these actions and tell me like which is the best one I should try and do for what I'm trying to do? So it's gonna then go off and do that and say, try this. Then you say, okay, I'm gonna try that, and how well did that work or not work? And we'll cover that in the next slide, what that means. And then I give a reward back. And then it's going to learn from that reward and update the RL model and sort of rinse and repeat for the next one. So if I just double click into that, right, how do you build it? So again, if I'm building, let's say, a news web app, I have a user that interacts with the site. And the idea is like, what do I show them? So when the user comes in, I have some context about them. They may be logged in, so I may have a lot more context about them. They may not have been logged in, and I may have less context, but I still have context, like what kind of a device they came in, what's the day of the week, what's the time, roughly what the geo area is. I may not know the exact precise location. I may. If I have more historical information, like I know who they are from my CRM, I can enrich this. And then, often many enterprises have this customer 360. Um, uh, I can pull in elements of that. I may be able to do some already MarTech and segmentation of these users based on this profile. I may call other third-party services to further enrich. And so I can do all of this in sort of real time or batched or however, depending on my business case. So tapping into existing investments I've done to provide more context. To be clear, I don't have to do this, but if you already have it, why wouldn't you want to use it, right? So you're not throwing away your investments. And then similarly, in my news side, I may have recommendation engines from articles based on some of this. In this case, like locations and topics and what things I like or not like and so on. Those may further have been edited, refined by an editorial team. I may have a content management system, a CMS with that. I may knowledge mine a bunch of this stuff, right? So I can collate all of this together and then send this off to personalizer. Now, what happens is when you call the rank API, internally there's an inference model. This is the model in production right now it's using. That's inferring what is coming. It's taking in all this context, taking in the actions, and then figuring out what to do. An aspect of what to do is also, am I exploring or not? Am I going to try out new things? Or am I going to give you a result back in terms of what action to take, of what I already know as best? And we'll come to that exploring and so on later, right? So it figures out all of that and then says, try this. You send that back, and then the user interacts with it, and then your logic defines what it is, and you can give a reward. I mean, in a news app, for example, or a news website, a simple thing could be, did I open the article? Did I scroll? Did I scroll halfway or all the way to the end? Or how much did I interact or not? How much time did I take reading? So all of these can sort of factor in and sort of give a reward. And then based on your logic. And then once I get a reward in sort of near real time, I train them another model or working, my inference, the one in production, if you will. I can evaluate and explain what's happening on that. I can optimize it. And then basically, then that reflects my new model, which the next time around when it comes around, my inference is happening. But all of this, which is also simplified, but at a high level, you don't see it. To you, it's just two simple APIs. And then some of these you can control. You have knobs to tweak and control, either through the GUI when you log into Azure portal and deploy a personalized service, or through the API call as well. And some of this you can change per API call should you want to, for example. But then inherent into what's really making this work is this notion of discovering patterns and causality. And that's built into, I'm going to build this out, and that's built into RL, right? It's a key aspect of RL. So what exploit means is when a model is there based on a policy, when it's trying to do an inference on that, exploiting means I'm going to get the best result I have. This is what ML does. Every time it only exploits. It's like, what's the best answer in this context I have? And that's what it's going to do, send back. But then every now and then you may want to try out new things, other things. Is notion is called explore, and there's a percentage, and these have a healthy tension between the two. You can't explore all the time because you won't hit your performance goals that you want. Conversely, you should not only exploit all the time because you'll never try out new things which could give you better results. So there's a balance. And there's a tension in there, and that's what something you gotta go figure out. How much should I do or not between the two? But then how does it manifest itself? If you make a example between A/B testing and counterfactual evaluation, which is a fancy way of saying how in RL you do A/B testing, it's counterfactual. I can't tell you the future because it has happened. So it's looking through the past. So if you want to do an A/B test of a news site, if we stick to that, a typical way to do that would be I have to first design the right experiment. So I need to understand what the right experiment means like. I got to test it at least once online. I need to get data. I have a hypothesis and say, was it good or bad? If it wasn't bad, I have to go rinse and repeat, like try the next experiment. What's right or wrong? Then eventually I get to like, this is a good state. Versus in an RL based model, this whole notion of exploring as a policy is built in. The model explores and exploits and interacts the user, it records the user interactions, knows from that, and then finds the best policy for that sort of new model. And the key is the first one is more difficult, right? I mean, it's a lot of time to go through and so on. But the latter, I can do thousands of these sort of in running because I'm always exploring and exploring. It doesn't mean I'm promoting a model. I can always sort of hold it off. So much more powerful. And then one key aspect of RL is this notion of a cold start. So when I have a brand new system, I have a brand new model I'm going to deploy. Uh, it has no knowledge of the world, right? It's like a toddler or a baby. It's sort of learning. And the only way I can learn it is in production. And then, of course, these new deployments take time. It depends how much volume, how much data you're feeding through. The slower or the lesser amount of data, the longer it'll take to train. The more amount of data, as in the number of calls, the quicker it's going to train. And then sort of to alleviate this cold start problem, which is an RL thing, one of the techniques we came up is this, what we're calling apprentice mode, which is in preview right now. So it's a learning behavior that addresses this cold start constraint, right? It allows you to get confidence. And what it is, it's like an apprentice. It's watching over as your current business logic is working. So it's not impacting that. It's not changing your answer back or your reward back. So if your current logic says, oh yeah, I'm going to give that a 0.8, and this says, I'm going to give it a 0.2, then it goes like, oh no, I was wrong. It's a 0.8. So it's learning from that. And the next piece along, it's learning from that. And it's validating its action in the context, and it's getting smarter and smarter. At some point, it's good enough. It reaches some kind of a threshold. And it's sort of and then when it reaches a threshold, at that point you can switch the apprentice mode off. So instead of it being an apprentice, it's become a master, or it's no longer an apprentice, right? It's learned enough on the job, if you will. But when that threshold is met, it's not still impacting your business model, and then you can choose to flick it all. And then the key is you're not doing any of this by changing any line of code. It's a simple config switch. You can switch it on and off sort of to do that. And then a key aspect that goes with this is counterfactual that we touched on. And if I zoom in a little bit to the screenshot, right? I mean, what counterfactual does is it's all these experiments I'm running, all these strategies I can run where I'm changing my rewards and my confidence of those, how they're changing, and I can give it a name and so on. And we throw in a random just to make it statistically accurate. And then once you're happy with a certain one, then you can apply that as your sort of new base class, if you will, your new base model, if you will, in production. And of course, you can export these and sort of play offline. If you're a data scientist, you can explore more. But then a key aspect of it is like, look, I have all these features. Which one actually is making sense? Excuse me, versus which one's not? What's real versus noise? And so this gives you actionable insights into that. What are the good features? And if you hold this juice and drink and pasta for a second, we'll see it coming to life soon. And then what features are actually like nutrition level here, is not really adding anything. What's noise? So I can learn that. So how does it happen? So let's say I'm building a web app, simple Knockout.js, simple web app to understand food preferences, right? So Amit logs in, what kind of food should I show him? So I have some context and user information, like I have time of day and so on here. I can have taste features. I have a sweet tooth, for example. So if you show me sweet, I'll always be happy. If you show me spicy, I'll be maybe less happy, right? So and then I have a number of actions. If you remember, we've been talking about the choices I have or the actions I have. In this case, if you remember, we talked about juice and pasta and so on, right? So my actions are these food items. Do I show juice? And then there's other attributes or context about those actions. Some I care about, some I may not care about. And then salad and so on, right? It's a list of these actions, and these IDs could be anything. They need to be unique in our context. I just call them that. And then, to call these is as simple as that. I call a rank API. I give it a list of actions. I give it the context I have. I could exclude actions. I can say, look, even though this is a longer list, here's the stuff, please don't consider this. For example, I'm a vegetarian. So if you have meat-based food items, you may want to exclude that. And then there's an event ID generated, which is sort of a GUID for that rank call. And then at some point later, I come back and give it a reward based on that action. Maybe I give it a food, you're trying to sell me stuff, maybe buy groceries for it, or whatever the case may be, right? Based on your business logic. And I can come back, in this case, I'm giving a 0.7 reward. Correlated with that GUID, right? So from using it, it's as simple as two simple APIs. And then I want to flick over and try and actually see if we can do a demo. We bootstrapped here already. So if this is a news website about sports, the goal here is, can I come and show me a personalized article on what is possible versus not? And last time I tried this hung. So I'm going to try and see how. If this hangs again, I might come back in the end and do this. I'm going to show you some code because I don't want it to hang again. But that's my web app. I'll show you later how you can run this. It's actually, let me do that. I mean, it's part of our samples. So you can just go to GitHub, the cognitive service samples, and then pull this down and then actually run it locally if you want. But again, it's as simple as, if you here you see, look, here's my example of the features. I have taste preferences for the user. I have a list of actions. And if you notice, if you might remember, some of you might have noticed, one of the noises features that was adding noise was nutrition level. But here I have a lot of nutrition levels defined, right? So I think it's really important that a user is making a choice based on nutrition level. Turns out they don't really care about it. So here's my list of sort of actions, if you will. Could be anything else, right? In our simple example, I package it together and I call it, here's the actual call I make, but here's what I'm packaging together. And then I can generate my reward. In our simple web app, you manually put in what a reward would be. And then I go and call a reward out, right? So it's as simple as that. And we'll come to the web app in the end if it still doesn't crash, or we'll have to do it live. But then what's also important is, with great power, I mean, you're calling this quite complex RL machinery behind the scenes with two simple APIs. You may or may not care, you may or may not appreciate, but with great power, comes great responsibility. And responsible use and responsible AI is something that we at Microsoft take very, very seriously. And it's something that's built in and not bolted on, is the analogy I like to use. There's a dedicated team and a process around this across engineering. There's this notion of a harms model, which does an assessment and a threat model for society. And it's embedded, right? I said it's built in, it's embedded into the full product lifecycle, right? At design, at document, at implementing it. During ship room, we can't ship without this. There's special ship rooms just for this. And then there's also elements of for you, and then key in this is this notion of two things like transparency notes, which tell you when you are using this in your business for your outcomes, for your customers, like how a model is designed, how it's trained, what's the risks of the data. And then in responsible use guidelines, it's telling you things like, when should I use it? When is it not a good idea? What kind of data bias do you need to be wary of? And what are the common mistakes and patterns and so on, right? So responsible use is something super critical and sort of built into this that we are quite considerate of. Just to quickly, right, with responsible use, there's transparency notes, you need to be wary of things, how you use as guidelines and so on. So it's all there. Another example I wanted to use, not just personalized, was what we call an anomaly detector. And basically it's learning from the past. It's the ability to dig deeper from historic causality and looking at trends and time series and picking up things that are odd or starting to look odd. And so they're not an anomaly, but they could be. And it's a combination of various machine learning and deep learning techniques. And basically it helps you foresee things before they occur, what's unusual. And then it can take time series. It does take time series as an input. It auto selects a model from an ensemble for inference, and then returns metadata associated with that. Now, if any of you've dealt with time series, you'll actually appreciate it's quite difficult to get into the nuance. For example, from this ensemble of algorithms, the first example is very, very different from the second example, right? If you want to track KPIs like revenue and understand why something is out of whack in the context of a historical pattern, for a revenue stream of input is very different than a sensor stream of input, which could imply a malfunction because, let's say, a temperature control or a vibration or something is out of different. And the same algorithm cannot really work on the other one necessarily. So the fact it can auto-select from this, again, helps you make into that bit better decision, allowing you, when you think about decision AI, and it's a PaaS architecture, containers are supported. But the beauty of it is, again, is from this is it's a simple API. I can detect anomalies. I can find anomalies. I can find a trend change point in a time series. So again, it allows me to, if you go back and think about decision AI, it allows me to find a different or a better decision, as opposed to as that's changing to a reacting world rather than sort of just a more staticky, if you will. And then I wanted to move on, and give you on, okay, this is stuff in production, which is out there. It's new, but it's been there, and we'll give you examples towards the end. But I also wanted to touch on some areas like peeking into the next set of things. And optimization is an area, and then that is coming out. And this was something we like to think about, like from research to production, like sort of if you think about a pipeline, right? And optimization and decision, these sort of AI scenarios can be across various things. I could optimize over an existing policy. For example, resource allocation. How do I allocate a new VM when you spin up something in Azure? Do I do it on an existing machine? Do I do it on a new machine? Why should I do it and when? And how do I maximize the best benefit both for you and sort of me, if you think about it? I can learn over this notion of continuous actions. Like dynamic pricing. It's not one switch or one setting and I'm done. I could have multiple knobs and tunes. I'll have to all sort of tweak and turn across a series of these steps, right? And then many parameters is that tweaking and turning of that knob, right? It's like dynamic pricing is not tweaking and turning of the knobs only, but multiple steps. But then tweaking and turning of the knobs is that. And then there's this notion of multi-shot, right? At the same time, I wanted to optimize many things together, and then how can I do that, right? So these are complex science algorithm problems, and we're going to show you how we're getting some of these to research in the context of just optimizing. So when we think about optimizing, it actually can get very, very complex depending on what we're trying to do. If I step back at a high level, there's sort of three scenarios we're talking about in optimization. So there's this configuration and policy, right? What's the right thing in terms of configuration? Like if it's insurance, what's the right threshold? Or if I'm restocking in a hospital for medicines or drugs and so on, like how many gloves or syringes should I stop, reorder? How is that different now in the pandemic than, let's say, a year ago, 6 months ago? Then you have this notion of traveling salesman's problem or graphs. How can I create the shortest route between things or optimize the production output or execute on better total time? Or this notion of a knapsack. Think of a knapsack like as a backpack. Like how much can I stuff in it without breaking things? So how many containers can I run in a VM given the constraints I have? For those who know me, one of my favorite saying is laws of physics and computer science don't change. So like the VM ones is an example of that, or batch expenses and approvals, or how much do I charge a drone given my finite resources battery so I can still complete a flight path I'm thinking of. I don't want to overdo it. I don't want to underdo it as well, right? So these are called sort of at a high level, these knapsack problems. How can I stuff these at the right level to still maximize it? And then you have also classes of optimization. We touched on this in the research thing I was trying to show you a couple of slides ago. You have sort of single-use optimization, like AC placement or loading delivery tracks. Like it's one time, I'm done because I have all the information, I have a choice, and then I'm good with that. And then you have this continuous optimization, right? It's ongoing. There's many steps and many observations I can do. Again, if you think about RL, my environment's changing, my actions, and what I'm seeing may not necessarily reuse. So how can I keep building that, right? So it's continuing. There's no sort of one answer and I'm done. And then you have like a single step or a single decision. Different from a single use. Single use is one time and I'm done. AC placement, let's say in a factory or a hotel or something like that. Where a single step is next best action. It's a single decision for this context. It could be different for every situation or every subject. as they come. And those situations may or may not repeat themselves, right? So if you think about the classes of optimization, they also go around that. And those are some of the things we're thinking about. So just to make it real, like, if let's say you're doing a delivery truck, especially with everyone back, if you're using just our real world today, many more of us are shopping online than we ever did. More packages being shipped, different kinds, different categories, different thresholds, and so on. So how do you optimize that, right? Again, all my history doesn't quite teach me anything on that. ML model doesn't really quite work. So in this case, I can have my inbound sort of how do I optimize a manifest? How much and what should I grow into a truck? So I can have a incoming data of like packages, 50,000 packages I have. Which truck should I go in? I can call something like, a model, AI service, decision AI service, which can train and update and inference with policies, right? Explore, exploit, you understand a little bit of that. Based on that, I can generate a solution given the constraints I understand of the packages. Again, that's my context. I can have things like time limits reached or some other threshold received as I'm simulating it to an approximation function or using an approximation function. To be clear, this simulator is sort of low fidelity, not the simulated RL that we're talking about. And I have historical data and operational data for that. So I can use all of that, and then I can evaluate a best solution score and then send that back to you on what to do and use, and then get you the best fit or the best solution for that, right? And then there's a way in optimizing that I have to take in multiple factors. It's destination, routes, what do I have available, how much, blah, 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 right? A bunch of that stuff goes into that. So then how do we make this real, right? We've touched on what is decision AI, what's RL, on personalizer, on anomaly detector, optimization. So I want to give you some examples that we are running today in production. Now I have a set of Microsoft examples because I cannot use our customer examples. I don't have the permission. Hopefully by the time the conference is done, we will have some of that publicly and we can talk about it. But we use personalizer, for example, for Microsoft.com. And with apprentice mode, we sort of had apprentice mode running in for 2.5 weeks, and in 2.5 weeks, it matched sort of 85% of the recommendations that it was doing, and that was good enough as a threshold to sort of switch it on. And in 2 weeks from graduating from being an apprentice, there was a 19% uplift on the homepage, and a lot of this is on the deals. It's personalizing the product list, and then the reward was have you clicked on that product list or not. That then goes into trying to sell you something or show you more information about something and so on, right? So this product could be different types of Xboxes, hardware, software, accessories, and what have you, right? So the reward in this case was did you actually interact with that click or not? And we saw a 19x uplift just on the homepage in 2 weeks after going sort of live from apprentice mode. Xbox.com, not Xbox homepage, not Xbox.com. If any of your gamers, so when you load your sort of home screen, if you will, the main thing in the middle is sort of the hero position, it's called. And then the 7 secondary sort of positions around it. All of that, we saw 40% engagement uplift from when Xbox was using on. Again, the idea was, did you click on it and engage in it? So did you load a game or something else? MSN News, 25% improvement through that, personalization of news content. And this is one example where especially the breaking news section, there's a new RL model deployed in production automatically every 5 minutes, which kind of makes sense if you think about the breaking news. My world's changing so fast. I don't have really time to get data, label it, train it, have a new ML model. I test it. If I'm happy with it, deploy it in production, and that whole life cycle usually takes weeks or months. I mean, it's not unheard in a typical enterprise for it to be 3, 6, 9 months. And here we have the model in production every 5 minutes on its own, specifically in the breaking news section, right, where it kind of makes sense. And then this one I'm quite pleased about. We actually see this every day. For those who are on the Microsoft ecosystem, you may or may not realize it, but we're using optimization, we're using RL to optimize something that we care about is call quality on Teams right now. So what most people don't realize is when you want to, there's something called a jitter buffer. If you ever run like speed test, Ookla speed test or something, you'll see a jitter buffer as a parameter. It shows up in the result. Now this is not a unique value for everyone. It's as a global value. It's a unique value for everyone. And so there's no sort of universal setting that's best. And there's a lot of factors you need to think on that you need to do. And this jitter buffer is something that if it is off, your call would be horrible. It keeps drop. There's a lot of latency. It's a lot of patchy. You sort of hear the alien voice if that's you've heard it or whatnot. And there's a lot of delay, right? But if you get it right, then the sound quality is good to acceptable, depending on your connection. And there's a lot of factors that goes into this sort of jitter buffer setting. Again, there's no universal, like I said. It has things like your network connection. Are you using a headset or not? Are you on Wi-Fi or cell or a broadband? What kind of hardware are you on? Are you using video? What hardware on that? The parameters of that. So you have to take in sort of, again, without having one universal thing, what it has to do is it has to take in all these, I'm going to fill this out, right? For this jitter buffer setting, it takes in all these different attributes and what it needs to do for that RL model that is training. And then based on what it's learning, it says, try this. I think it's this setting, and that's what it does. And then based on the telemetry as the call's going on, we know if that was a good option, good opportunity, good choice or not. Did it actually work or not? And based on that, you get a reward, and then you learn from it, and then the model keeps updating. Again, you don't see this; you're just making a call. One signal also we get, you'll see again. Sometimes you'll see when you end up a Teams call, you get a 5-star rating, a user one saying, hey, what was the quality of that? Or how was that experience? 1 bad, 5 good, and sort of that scalar. That's one another reward we're getting from the user to assess, because that helps us learn, and you sort of try and avoid this notion of what's called the watermelon effect, which some of you may have heard of. If you think about a watermelon, it's all green on the outside, so my status is good. But the minute I start digging into it, it's all red and horrible. So our telemetry might say everything's great, but that may have been the most horrible in the world. And that's one way we learn from that and train the model. Another one I want to talk about, which internally is called Project Skylight. It's the Windows Get Help. Now, this is a little stale data, but still very powerful. If you've tried this if you're on Windows 10, or if you go to support.microsoft.com, what it does is this agent resolutions. It's the bot, it's the Get Help virtual agent that improves the resolution of the problem using, again, in this case, it's using, even though it's decision AI, it's personalizer to predict intent, what you're better after. So for example, you say my printer is not working. The things it should show you based on all the context on who you are, what machine you're logged in, where you're logged in from, if we know you, have you come in before or not, right? So it's trying to pull in all of that and then tell you what should you try to make it as sort of fix the problem for you quicker. And then we ran it through a subset of the traffic at 37 million sessions on an annual basis. That's a subset of the traffic. And it improved the resolution by 6%, which is massive compared to that, right? And this is like what that team came back, right? And it's now live with 100% of the traffic. It's the model behind it. You mean blah blah blah, and the KPI show it's winning a lot. And what was really interesting was the model was iterating in just hours once it went live, and it went live with just 2 weeks of flighting, right? I mean, that is super critical. So if I stop there in the interest of time, we're getting to the end, personalizer and other decision AI is in production. We are using it at scale across various things. There's a bunch of third-party customers, can't talk about it right now, but it's proven, it's in production for a while. It's quite radical in different ways and things it allows you to do. But then the beauty of it is it expands to the scope of problems as you are going, right? Because of RL, it's about what you're suggesting, what you're observing, and the rewards changing, and it allows you to go back that decision AI apps you build that change to the revolving, changing world. So in closing, when building apps that adapt, here's the things you got to think about, right? And then if you want to go learn more on cognitive services, there's the links on personalizer, anomaly detector, and others that you will come on. But I want to open it up for questions, and I want to thank you, and I hope you all stay safe. I am sorry the demo didn't work. What I can do is, now that we're at the end of this, I can try it again and see. So I'm going to try it again and see if that actually uh, uh, works or not. So I'm going to pull it in here and see. Yep. So in this case, sports one, right? So I have a number of news articles to show, the images to show, and so on. And it can show this. And then as I interact with it, you see I scroll, so I got an engagement of one or not, and then I can see over time how people are. This is counterfactual. Which article was engaged better or not, and over the last 100 visits. And then if you want to see how it works, I have how am I coming here? So I have metadata, right? What's ongoing, what kind of a device, and so on. I have some that's built into the context. I have a number of articles to show, right? So in this case, it picked this one. So here's my list of articles to show. That's my JSON, if you will. Based on that, I have if you remember, we talked about the event ID. That's a GUID. It comes back. Based on that, the model is choosing: am I exploring or am I exploiting? In this case, it was exploring, based on all the other things and the thresholds I have, and it also got a reward of one because I scrolled in this case, right? So you can understand a bit more on how it's working as you go through this. Now, if I refresh it, I may get something different. Actually, the problem is because we get so much traffic through this that exploit overweighs some of the other ones we're talking about. So I'm in this case happen to be get the same one, but that was the real demo. And then AKA personalizer. If you go, you can go read up more about this and read in this category of decision AI. With that, I will stop sharing and I'll thank you, and I'm open to questions. Thank you very much.